Okay. Okay. Can you answer this question? Question number second. In one film model, CO is produced at the carbon particle surface. CO2 is produced at the carbon particle surface. CO2 penetrate toward the surface. Reduction reaction occurs at the surface. Okay, so in this case, this is the reaction that take place at the surface in one film model. So now can you answer this question? No. So sorry. There is a mistake. There is a mistake. By mistake I said it. No. This is not the reaction that take place at the in one film model. This is not the reaction. See, in this reaction, this is like different. Just okay. This is one film model C plus O2 CO2. So can you answer this question now? Can you answer this question? Sorry. By mistake I said that this reaction does not take place at in first one film model. This is not the reaction. By mistake I said this. So in second, can you answer this question now? In one film model, can you answer it? Someone of you? Any one of you? See, this is one film model. At the carbon surface, the reaction is carbon plus O2 CO2. So can you answer this question now? Izadul Rahman, are you there?
Yes, sir.
Yes, sir. So can you answer this question?
It says CO2 is produced at carbon particle surface.
CO2 is produced at the carbon particle surface. Okay. So in one film model, net mass flux of the carbon is
Mass flux of CO2 and mass flux of O2.
mass flux of CO2 plus mass flux of O2. That's what you are saying.
Yes, sir.
On what basis you are saying?
Uh, According to previous question,
No. That answer is not correct. See, you think this is the reaction. So what is the mass flux of carbon? Yeah. See, now this carbon is reacting with the oxygen and it is producing the CO2. So can you answer the mass flux of carbon? Mass conservation will always happen, right? So now, no. Can you answer this question now? Can you answer this question now?
CO2 minus mass flux of CO. O2 minus CO2.
O2 minus CO2 or CO2 minus O2?
CO2 minus O2.
CO2 minus O2. See, other than Harsh, can anyone answer like why CO2 minus O2, not O2 minus CO2? Just see this equation and you will get the answer. Yeah. Okay, see the mass. See, if you see this, for 1 mole of carbon, 1 mole of oxygen, 1 mole of CO2 is forming. So mass flow rate of CO2 is more than the mass flow rate of oxygen. So molecular weight of CO2 is higher than the molecular weight of oxygen. Okay. Okay. Now answer the question number 4. See this question, like you can answer if you have gone through the PPT. Only then you can answer. But try to answer this question. But yeah, you can make a wise decision. You can make a wise guess. You can make diffusion coefficient T. Resistance to diffusion of oxygen to carbon surface is directly proportional to.
One upon D.
1 upon D, yeah, 1 upon D. Yeah, 1 upon D. On what basis you are saying?
Sir, mass diffusivity is given by rho into D.
Yeah. What you are saying? Mass flux is equal to the
Rho into D.
rho into D.
This is the mass diffusivity. Rho into D.
No. Rho into D. D is the diffusivity. The mass diffusion coefficient. D is the mass diffusion coefficient D.
Yes, and rho into D will be mass diffusivity.
Mass diffusivity you are saying.
Yes, sir.
Rho into D will be mass diffusivity. Okay, see, like I don't know mass diffusivity. Like I'm not able to at this point. I'm not able to get like how mass rho D is how mass diffusivity. D is the diffusion coefficient, that what I know, and this is the fixed law of diffusion. So if you do that electrical analogy, then you will get 1 upon D. So DC and DC upon 1 upon D, that you will get. From there you are getting 1 upon D, and there it is not like resistance is not 1 upon D. It is one equation is there, and D is in the like denominator term. On that basis you are getting. Okay. See, someone want to say something. Someone is saying something. Okay. Question number 5.
Particle radius is small.
Particle radius is small. Okay. So anyone else can answer this question? Okay, so correct answer is particle radius is small. Okay, question number 6. Question number 6. Can you answer the question number 6? Okay, so this is the reaction that take place at the surface, at the surface of the carbon particle. Carbon plus CO2. This is 2CO. Okay, so guys, can you tell me, is this the oxidation reaction or the reduction reaction? This is a reduction.
Oxidation.
Reduction, right? Is this the oxidation?
Sir, the first one is oxidation.
You are saying this reaction is oxidation.
I'm confused.
This is reduction reaction because CO2 is converting into the CO. So oxygen is decreasing. So it is a reduction reaction. This is oxidation. CO is converting into the CO2. Okay. Okay, fine. So can you answer this question now? In two film model.
Second option.
CO is produced at the carbon surface due to its surface reaction with CO2. Carbon react with CO2 and it forms the CO. And further oxidation take place. So, but this is the reaction that take place at the surface. Two film model. Okay. Now try to solve the question number 7. See, just I want to know, like every one of you have you gone through those lecture 12, like week 12 content, or you are yet to go?
No, sir, I only finished my first lecture. Actually, I am the other engagement with the other subject. I am having the exam on the 15th, so it is not possible for me to go through all the lecture. So maybe by next week I will be able to complete all the lectures.
Okay, okay. So, okay, try to think about this question and then I will explain. First read it, think about it, and I will tell you something. See, basically, they have given the empirical correlation for Kc, kinetic rate constant, and diffusion coefficient d at the temperature T. So you need to use this Kc and T and find that a surface temperature and the mass burning rate of carbon. Okay guys, see, you need to use these two, like they have given kinetic resistance and diffusion resistance are same, so you need to equate these two correlation, and then you need to find that this surface temperature. When you find the surface temperature, like after that you, like first you find the surface temperature, then you find the mass flow rate of what they are asking. Resistance to the diffusion kinetic surface reactions are same, corresponding mass burning rate of carbon, then you find the mass burning rate of carbon. This will give you the mass burning rate of carbon. See, only the the what I can say, like you need to equate this. So okay, I will solve this. Guys, are you getting what I am saying? In this question, what they are saying, that resistance to the diffusion and resistance to the kinetics of surface reactions are same. Okay guys, is this okay? Are you able to understand what I am saying? Please say yes or no. If no, so that I can explain one more time. See, it is given in the question, R kinetic is equal to the R kinetic is equal to the R diffusion. So R kinetic upon R diffusion is equal to the 1. Just I am like R kinetic, so this equation and this equation upon 1 is equal to the 1. So S upon S plus constant, this is a mass fraction of oxygen at the surface into universal gas constant, temperature at the surface, molecular weight of the mixture, partial pressure, rho, density, D is the diffusion coefficient, Kc, this kinetic coefficient Kc and Rc is the this particle radius. So just you need to do R kinetic upon R diffusion, so you will get this. Okay. Mass of O2 upon mass of carbon, so it will be 32 upon 12. This will be 32 upon 12 will come somewhere around 2.66. 32 upon 12, so 2.66, 2.667. This is S. Assuming oxygen mass fraction at the surface is 0.01, S is so Y of O2 at surface is equal to the 0.01. This density I am like using that PV is equal to the MRT. I am writing density is equal to P upon RT into molecular weight of the mixture into diffusion coefficient upon Kc into 1 upon Rc. Okay, guys, can you tell me what is RC? Someone can tell me what is RC here? See, while I am solving, you should be knowing like what I am doing. Otherwise, it won't be useful. Can you tell me what is RC? Because I have already told you this like while I was solving this. Can you tell me what is RC? There is D. What is D, KC, and RC? Izadul Rahman, can you tell me what is RC?
Droplet radius.
Droplet radius. RC is the droplet radius, and it is
Double.
100 micron, I think. No, 200
Yes.
micron.
2.
No, this is diameter is 200 micron, so radius will be 100 micron. RC is equal to the 10 to the power minus 4 meter, and there, like how we can calculate D and K. Can you tell me how to calculate D and K? What is D? What is D? Can you tell me what is D?
D mass diffusivity.
Diffusion coefficient D. Diffusion coefficient. Mass diffusivity. D is mass diffusivity. See, I'm little bit confused. Like, what is mass diffusivity? D is the diffusion coefficient, not. You can check at your end. Diffusion coefficient is also known as mass diffusivity, but D is diffusion coefficient. That okay. What is Kc? What is Kc?
Kinetic reaction constant.
Kinetic reaction constant. So, can you tell me how we can calculate this?
Yeah. No, sir, don't know, sir.
So this relation is given, right? They have given this relation. From here we can get the diffusion coefficient at temperature T. So this relation we will use this relation to calculate D. Now from this relation we will get K, kinetic rate constant. From here we will get K. Kc is equal to the 3 into 10 to the power 5 into exponents of minus 7966 upon T into S. So we need to substitute these value and we will get one equation, one unknown. What is unknown? What is unknown here? See, these two are the relation for that kinetic rate constant, that resistance, kinetic resistance, and this is diffusion resistance, and they have given kinetic resistance is equal to the diffusion resistance. So we have written R kinetic upon R diffusion is equal to the 1, and now we are getting this, like just you need to write R kinetic upon R diffusion, you will get this equation. From here what is not known, like what is unknown, that is the surface temperature. We need surface temperature, so that is unknown. And other things, like just we use that PV is equal to the MRT equation, and finally we got this D and K we know from this relation. Now if we substitute this value here, we will get one equation, one unknown. So this will be 1 is equal to the 2.667 upon 2.667 upon 2.667 plus 0.01, 0.99626, 0.99626 into d400 into Ts surface temperature, Ts upon 400 to the power 1.5 Kc into 1 upon Kc we will write here. So we can write like upon 3 into 10 to the power 5 into exponent minus 7966 upon Ts into Rc. Can you tell me how we can solve this equation? What is D400? Can you tell me what is D400? Guys, can you tell me what is D400?
One point 65 into
What is D400? Basically, it is diffusion coefficient at 400 Kelvin. What is RC? RC is 100 microns, so 10 to the power minus 4 is equal to the 0.99626 into D400, 1.65 into 10 to the power minus 5 into T upon 400 to the power 1.5. See, one equation, one unknown, but we cannot solve this equation because this is like some non-linear equation, or like this is some, what we can say, like exponential equation, so we have to solve it numerically, right? So like just to simplify this equation, we can take log on both sides. See, even if you want, you can solve this equation, but you have to use some like either MATLAB or Mathematica. You have to use something like this. So to simplify this, we can take log on both sides and then we see like what we are getting. If we do this, what we will get? Log 30 minus 17,966 upon TS is equal to the, what is 0.9962 into 1.65 into 1.65 into 10 to the power minus 10 to the power minus 5. So it will be 1.6438 1.6438 into 10 to the power minus 5. So this, wait. It will be log. Is this a log or it is ln? Can you tell me, is this a log or is this ln?
ln, sir, ln.
It is ln, because this is base e, not base 10. See, if we want, we can take log also, but in that case, what we will get? Log e base 10 into log e base 10, right? Say yes or no.
Yes, sir.
See, if we take log e to the power something, maybe x, what is this? X into log e base 10, right?
Yes.
This is ln. This is ln 0.99626 0.99626 into 1.65 into 10 to the power minus 5 plus 1.5 into ln t upon 400 ln 30 minus 7966 upon ts is equal to the, this if you see guys, can you multiply this and tell me what is this? 0.99626 into 1.65, 0.99626 into 1.65, 1.65, how much you are getting? 1.6438 into 10 to the power minus 5 plus 1.5 into ln t is ln t minus ln 400. Is this fine? See, we can bring this ts and ts term, this is ts in one side and other on other side, other term on the other side. What we can do, like 1.5 into ln ts plus 7966 upon ts is equal to the, basically like I am bringing this term this side, 1.5 ln ts plus 7966 upon ts and remaining term this side, so it will be ln 30 minus ln 1.6438 into 10 to the power minus 5 plus 1.5 into ln 400 Okay guys, can you solve this whole equation and let me know what you are getting, because this you can get ln 30 minus ln 1.6438 into 10 to the power minus 5 plus 1.5 into ln 400. ln 30 minus ln 1.6438 1.6438 into 10 to the power minus 5 plus 1.5 into ln 400
Right side of the equation is 23.403.
23.403 40, yeah, 43
4,
I
4,
get it,
4.
4043.
Right.
Now ln ts ln ts plus 17966 upon 1.5 into ts is equal to the 23.4043 upon 1.5. See, let me tell you one thing. This question is not difficult question. There is no such lengthy calculation or something. Only the thing is you should be knowing this. Everything is given in the question. You should be knowing this, and after that this question is easy. See, you need to know these two relations. If you know this, you can solve this question. Whatever calculation we are doing, we are just making the, because this equation is not something like ax square plus bx plus c is equal to something. So we can solve this, solve such equation. But this is some logarithmic equation. We don't know, like we don't have any standard formula to solve this equation. So we have to solve this equation numerically. Now, just to simplify this equation, we are doing this 17966 upon 1.5. So if you do this, you will get 23.4043 upon 1.5, 15.6. So this will be ln ts plus 17966 upon 1.5, 17966 upon 1.5. It will be 11977, 11977.333 upon ts is equal to 23.4043. 23.4043 upon 1.5. So it will be 15.602. 15.602. Now we have to use some software, or we have to use some Mathematica or MATLAB to solve this, because otherwise we can't solve this. Like using some iterative method only, using numerical methods only, we can solve this. Just give me a minute.
Is it a 1438?
1438. Yeah. See, you can do one thing that also you can do. Like, suppose that you know the equation and you know this options. This thing you can do. Like, you know the equation and substitute these options and see like which option satisfy the equation. See, such question they won't ask in the question. They won't ask in exam, but they are asking that it may be like they will give like it will be optional question only, then they can ask, because no one can solve this like iteration, no idea like where to start or like how to start. No, like as such we can solve this until unless we have some idea like some range we know, only then we can solve. Yeah, so suppose that four options are given, so you take one of the option and see, or else suppose that you have something, so you put this equation in MATLAB and then solve. So as such here you can do what you can do, you substitute this equation and see whether it satisfies this or not. So you like ln ts, consider one option, ln 1438 plus 11,977 point triple three upon 1438. So we are getting 15.6. So first option satisfies this equation. So that is correct.
Sorry, sir. Sorry to interrupt you.
Yeah.
In a calculator, directly we can use the shift solve formula, right?
Shift.
So we can use shift.
Yeah. Shift.
Huh.
Yeah.
Yeah. So by using that formula, you can solve the equation
See,
easily.
I'm not getting how to use that shift. Shift.
Okay. Actually, I have a scientific calculator.
Yeah, I also have scientific calculator this.
Right. So by using shift solve, you have to write the equation, type the log like that. Then you have to use alpha, then solve equation, okay, equal to sign, and then you have to put and shift solve, you will get the answer.
Okay. This also we can do. Like
Yeah.
log we need to find log base e.
Yes, you can write the log into bracket. Then you have to press the alpha, then select the x, then bracket get completed plus then 11 9
Okay, see, now you have to use
7 7
something like that. I don't know how to use this in that, but you have to use something, some scientific calculator or something like that, or some software. Only then you can solve it. This is how you can do it. Now to how to calculate the second part. Okay, second part is like mass burning rate of carbon. Second option is mass burning rate. Second question is calculate the mass burning rate of carbon. You know R kinetic. This is the equation for R kinetic. Now you know TS. You know TS is equal to the 1438. 1438. You know S. S is equal to the 2.667. 2.667. So using this equation you calculate R kinetic, and using this equation you calculate Y diffusion, and then you substitute this Y O infinity they have given. Okay, we will calculate this. What is the molecular weight of the mixture? Can you tell me what is the molecular weight of the mixture? Can you tell me what is the molecular weight of the mixture?
Thirty kg per kilomole. Mean molecular weight of the gases.
So the molecular weight is 30, right?
हाँ.
Now we need to find Kc. What value you are getting for Kc?
1.125.
1.125. 1.125. 1.125.
Sir, I am getting R kinetic very huge.
How much you are getting?
7.57 into 10 raised to 9. Is it correct?
7.
57.
Just give me a minute. 7 point R kinetic you are getting.
7.57 into 10, raised to 10 raised to 9.
7.7 into 10 raised to minus 9.
No, plus 9.
No, this is not correct.
Okay.
Please give me a minute. Wait. How much you are getting R kinetic?
7.57 into 10 raised to 9.
Okay, see. Please wait, I don't know it is correct or not. 7.57, please
Sir,
wait.
It is because sir, at the bottom it is 10 raised to minus 4, and that is a square. So it will go in the power above. It
10
will
to
be
the power
positive.
minus 8. 10 to the power minus 8 it will go. And 30 into 1.5 into p. Here one p is also there.
Okay, okay, okay.
P is also there. So K kinetic will be R kinetic is equal to the 2.667 into 8.314 into 1438
Sir,
upon, yeah,
74.093 into 10 raised to 3.
it maybe just give me a minute, please.
Okay, okay, fine.
Can you solve this equation? Can you solve? Can you calculate this? How much you are getting?
Sir, whole or the bottom portion?
No, no, whole portion. No, whole.
Yeah, that is only that I am telling. It is 74.093 into 10 raised to 3.
See, I am getting this value 74216.22073 R. I am getting this. Okay, okay. R kinetic. Okay. Similarly, you calculate R diffusion. R diffusion S plus, here you calculate R diffusion. Y equal to upon, now you need density. Like here you have to use that equation. P upon RT, rho is equal to the P upon RT into molecular weight. P upon RT into molecular weight. So just calculate density. Can you calculate density rho?
Point 2542.
0.2542. That's what you are getting.
Yes, sir.
Unit is kg per meter cube, right?
Yes, sir.
Yeah.
Sir, wait. It is, as per your equation, it is 254.25.
Is there any mistake? What is the mistake that we are doing?
Sir, that 8.314. Actually, it should be
Yeah.
8314. If I'm not,
Yeah. It should be 8314 because we are
it is in
taking.
kilojoule. Above is a kilo, then that should be in the kilo only. Maybe.
Wait. Just give me that. See, just take everything in SI units, so it will be 1.01325 into 10 to the power 5, right?
Then it is
Okay.
0.245, 2542.
Just give me into 30 upon 8.314 into 1438.
That should be 8314, not 8.314 at the denominator. If you are taking in all the units in SI, still the 8.314 is in the kilojoule.
Just give me 8.314 upon molecular weight. This will give.
Sir, the quantity that you are taking, 8.314, it will be now in the gram, that is in the joule per gram per Kelvin.
No. Okay, I'm confused at this point. Like,
Sir, you have not converted all the units in the Newton or joule. The quantity 8.314, it is still in the kilojoule only. We have to convert it into the joule. That's what I am saying.
okay, so you are saying 8314 into 10 to the power. So this thing will be.
No, sir. What I am trying to say is, if you convert all this in the either Newton or joule.
Okay. See, this
So
will.
it
Just. See, this is like very basic confusion. Into 34. 8.314 into 1438. 1438. So it will give.
sir, now what I am trying to say is,
No.
the
Yeah. See,
about quantity.
if you do this 1 into 2, this will give in kg per meter cube. Is it not correct?
No, sir. That's what I'm trying to say. It is gram per meter cube.
It is gram per meter cube.
Sir, what I'm trying to say is, sir, above the pressure now you converted into the pascal, that is a Newton per meter square, correct? The pressure value.
This pressure value.
It
Yeah,
is
yeah.
it is Newton per meter square.
Okay,
Now
okay.
the quantity below should be in the
I got it. I got it. I got it. See that Newton have the unit in kg. Kg meter second. The Newton
no,
is kg meters.
sir, there is another issue. What I'm trying to say is, above quantity is Newton per meter square, that pressure value.
Okay, okay, okay.
And the quantity which is 8.314, it should be in the Newton meter upon kilojoule per kg. That is joule per kg. Here you written it in terms of gram per kg, joule per gram per Kelvin.
See at this point, like I'm a little bit confused. Okay, 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 okay. So it will be 8314. 8314.
Yes, sir. Yes, sir.
Okay.
Now it is inconsistent. So it is 0.254 something.
0.254.
0.254.
Okay, okay. 0.254. Yeah, it makes sense. Kg per meter cube, it makes sense. Because at ambient it is 1.3, so at higher temperature it will be 0.254. Okay, okay, okay. Consider this. Point 254. This is what 0.2542. Okay. R diffusion into diffusion coefficient. You need to find the diffusion coefficient D. That you will get from that relation D. What is diffusion coefficient D? You have this relation. Can you calculate this? What D you are getting? Diffusion coefficient D.
It is, sir, 1.124 into 10 raised to minus 4.
1.124 into 10 raised to the power minus 4.
Yes, sir.
Okay, 1.124 into 10 raised to the power minus 4. Yeah, yeah. This is correct. Yeah. So can you solve this 10 to the power minus 4? RS is 10 to the power minus 4, right? Is this correct?
Sir, I'm getting 66.88 into 10 raised to 6.
6, 6, 6, 6, 6, 6.
6.88.
0.88 into 10 raised to the power minus 6.
No, 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 sir.
6, 6.
Sir,
Yeah.
66.88 into 10 raised to into 10 raised to 6.
Just give me a minute. See, I am getting this value 6688.169. What is the issue? Harsh, are you there?
Yes, sir.
Yeah, yeah. See, you are getting this 6.6 point. What you are getting?
66.88 into 10 raised to 6.
Just delete. 10 is to 6. 66.88 into 10 is to 6. 2.667 plus 0.001. 0.01 upon. Is there any mistake here or what?
It is, I think, mistake from my side.
0.2542 into D 1.254 into see, wait. What is D?
Sir, you are right. It is
No,
6686.02.
no. There is a mistake. See here, D is 1.254 into 10 raised to 10 is to 10 into 10 to the power minus 4. So it will be 10 to the power minus 8. Right?
Yes, sir. Then my answer is correct. Above 1.
Yeah. So this will be upon 10 is to the 10 to the power minus 8. 6.6 6.6881 into 10 is to the power 10 is to the power 7. Yeah,
Correct.
this is correct. So now just mass flow rate of the combustion, this will be See here 7 4 you was getting 74216. I like 74216. So like this similar to that 74216.22 216.22 into 10 is to the power 7 plus 74216.22. Okay. It will be 1.4951 kg per second. No. 10 to the power minus 10 kg per second. Still there is a problem. Guys, there is some mistake. I don't know what is the mistake, but there is some mistake from either I have done the mistake or there is some problem.
Sir, what is y O2 infinity?
YG. No. That is a mistake. YO2. Assume that oxygen mass fraction of the particle surface is 0.001.
So y over O2 FS it is given.
No. YO2. This is YO2 at the surface. So YO2 at infinity. Ambient mass fraction. This is 0.233. Yes, you take 0.233. But still, 0.2233. How much you are getting? 0.233. 233. Y O2 infinity 0.233, not 0.01. By mistake I took 0.01. 0.233. How much you are getting?
So it is 3.48 into 10 raised to minus 9. So it is 0.00348. Sir, it is not in the with the range given in the answer.
Yeah. Okay, guys. See, like what I want. There are a lot of issues. I think like I have to see that and then I can explain. So, like today, like is supposed to be the last day. So we can take the one extra class, and in that class I will explain. Like one more question is remaining, and these 3 questions I will explain then. So you can take the one extra class at your convenience time. You can take like whatever is your is comfortable for you. That day I can take the extra class. because I have to see the question. There is no meaning like from last 1 hour I keep on making the mistake. So I have to see that and then I will explain. Okay, guys.
This weekend, is it possible or
Yeah,
next
yeah,
week?
yeah. Yeah, it is possible. Tomorrow, is it possible? Tomorrow at your convenience time, is it possible?
Sir, let other people to
Yeah,
respond
yeah.
in case of.
Others, others, can you speak? Yeah, Surabhi, what is your opinion? You are saying, I think
Tomorrow is good.
tomorrow is good. Okay, so tomorrow what time?
Same
Uh,
time, sir.
no, same time. Okay. Actually, I have some proctor duty, so that time I will be busy. So just give me a minute. I will
Mor-
say, like, let me
Morning.
tell. Just give me a minute. Just give me a minute. No, 6:30 is not possible. Tomorrow, not in morning.
Morning, is it?
Morning before 10 it is possible, but it will be difficult for me. Before 9 it is possible because till after 9 I have the proctor duty. So tomorrow, can we take at 8 o'clock? Is it fine? 8 p.m. night, 8 p.m. evening, not evening
Yes,
also.
sir.
8.
No problem.
Okay. By that time, like one more question is there from the previous lecture, and these two, I think these three questions are there. So I will explain these three questions and one question from the previous lecture. Till tomorrow at 8. Okay. Okay, guys.
Sir,
8 p.m.
uh,
evening,
okay.
8 p.m. Morning is not possible.
Okay, sir. I have mailed you regarding the issue, the answers in the last that
Yeah, I saw that.
assignment.
I saw that. See, that also we will discuss tomorrow only. That also we will discuss tomorrow. Tomorrow we will discuss, like, because tomorrow will be the last class.
Okay. And sir, one thing, sir, in the exam online, they are not allowing this calculator with us physical. We have to calculate from the calculator provided in the software. So in that case, sir, it is difficult
See,
to solve the numerical.
see, I see, numerically you won't be able to solve it. Yeah, yeah. I don't think they will give like question number. What, like they were saying, that question I don't think they will give. The question like this, I don't think they will give the question like this. Like where you are getting some logarithmic equation and you are supposed to solve numerically. I don't think they will give this question, or if they will give, then they may give the answer. So you put the answer and then see.
Okay, reverse engineering.
Yeah, that one. Because see,
Okay.
how you can solve? I don't think it is possible for anyone to solve this numerically if you don't have proper
Yes,
software.
sir. Sir, even sir, if this the shift solve function is not given in the calculator, it's difficult to solve.
Yeah, even I don't know how to use this shift solve function. I have to see.
Sir, you have to just write the equation as it is. You are seeing on the paper,
Yeah,
and then you have to solve it. You have to press shift and solve. So here the variable will be the x, and that's all. And you can proceed further.
okay, okay. So I will see. Okay, guys. So tomorrow 8 p.m. we will meet and we will discuss all the remaining questions. Okay, guys. I'm sorry for inconvenience. Like I have to go through the some lecture, and I only then I can explain properly. Like I'm not able to clearly. I don't know, there's some mistake.
Okay, sir.
Okay,
Okay.
guys. Okay, guys. Okay, guys. You can leave. Okay, thank you. sorry.